Hey guys, it's Papa. You probably heard about the recent really big earthquake in Alaska. Well, that is plate tectonics in action. So let's get into that earthquake and figure out exactly what caused it and how that relates to the massive plate tectonics activities that are happening on planet Earth right now. This picture shows the center of the earthquake's power. You'll notice it happened right off the southern coast of the Alaskan peninsula. This picture shows a kind of a zoomed out view of where the earthquake occurred. The blue circle circles Alaska. And you can see the Pacific Ocean is the kind of a purpley color there. And it is made of ocean crust. We've probably talked about that before, ocean crust. And that ocean crust forms one of the massive tectonic plates, crustal plates of the Earth. As you know, these crustal plates, both ocean crust and land crust, are constantly on the move, and this massive Pacific Ocean crustal plate is moving in the direction that the big red arrow is pointing. It's pushing up against the land crust of Alaska, and with tremendous pressure, and something has to give. This picture shows the Pacific Ocean on the left, and below the ocean, the area labeled lithosphere, is the ocean crust of the giant Pacific Ocean crustal plate. On the right, you have the continental crust of the Alaska Peninsula, and you can see that the ocean crust is being pushed and shoved with huge pressure down underneath the land crust. That is called subduction. The Pacific Ocean plate is being subducted beneath the Alaska continental crust plate. And this is not a smooth process by any means. Simply put, the subducting ocean crust gets stuck in its downward journey because of friction and resistance of the rock of the continental crust. And that sticking occurs about where the red circle, inside the red circle area. Well, the ocean crust during this whole stuck-up time continues to apply pressure. And the pressure builds higher and higher and higher until there's enough force on the ocean crust to cause it to break that deadlock. It overcomes that deadlock and makes a gigantic plunge of many feet, releasing the pressure, and that plunge is what causes the earthquake. It can also cause a tidal wave to develop. In the case of this most recent Alaskan earthquake, there was not a tidal wave associated with it, also called a tsunami. But this is some of the earthquake damage that was caused on the Alaskan peninsula by this 8-point plus score on the Richter scale. These same kind of subduction zone earthquakes also cause tsunamis, and this is a picture of the tsunami damage, kind of damage that can occur, resulting in the loss of lives of tens, even hundreds of thousands of people, as you well know. This is a picture of the island of Santorini, located in the eastern Mediterranean Sea. It was a subduction-related stratovolcano that erupted around 1500 BC, causing massive earthquakes throughout the Mediterranean area and tremendous tsunamis that killed thousands, perhaps tens of thousands of people. And it's interesting, a lot of the legends of the lost continent of Atlantis are associated with the island of Santorini before it erupted. And many archaeologists believe that because Santorini erupted around 1500 BC, that many of the plagues associated with Moses and the Pharaoh of Egypt can be directly attributed to the after effects of the eruption of the Santorini volcano and other volcanoes that erupted around that same time. This is a picture of the rock called serpentinite. You may remember from another video that serpentinite is all mixed in with ocean crust as it travels via plate tectonics across the earth. And the serpentinite acts as a lubricant. That means that if there's enough serpentinite mixed in with the ocean crust as it's subducting, then that reduces the probability that the subducting slab of ocean crust is going to get stuck against the land crust, and that reduces the probability of a massive earthquake happening. Okay, so that's the story about what caused this massive Alaskan earthquake that we just recently had, and how the earthquake relates to the gigantic crustal plates that are constantly moving on the face of the earth. So hope this was helpful, and if it is helpful, subscribe to the channel, give me a thumbs up, and I'll love to receive your comments about geology or anything else you got that you want to talk about. All right, have a great day. Pop out.